All right, everyone, let's get started. So Xen and ACPI, the ever-recurring topic of discussion in our Connect. So added pictures to make this session very interesting. So this whole thing about ACPI and supporting that on diverse ARM platforms is a little bit of a non-trivial problem, right? And so just to recap for the people who weren't there for the previous discussions, so the whole problem is because when you're booting Xen, which is a small, minimal hypervisor directly on the hardware, and you're describing all your hardware in ACPI, there are certain things that are described in AML code that Xen just can't read and access can't get to. And there are also certain things that Xen will consume that DOM0 should not be looking at. And we need some mechanism for Xen to tell DOM0 that you should not be looking at these devices, or you should be looking at a different version of these devices. But Xen can't, because it's a minimal instance, it can't go and modify a full ACPI block and recompile an ACPI block and basically change that. So it's also special on ARM compared to x86 because there are certain assumptions you can't make. You can't assume that the serial port is just there and there, or other things like that. So that was the initial problem we've been trying to look at and worked quite a way through. So Lenaro is working on this problem, and the work is being tracked in card 1291, and we're trying to update the blueprint so you can follow along as we go. So for human beings, where we are is that we have the Xen hypervisor itself booting completely on the FTP-based model with UEFI. And we also have booting on the foundation model, but that doesn't run UEFI, so that runs with a boot wrapper with a hack. But that means that memory is still described in the device tree node because the memory information is obtained from UEFI, not from ACPI. So that's the two basic working setups you can play with. So in Xen itself, we have support for gig, timers, CPU, getting the memory from UEFI, and for the UART. And that's all based on ACPI, not using device tree at all. So this problem of having to hide a device in from DOM0, the previous approach we were working on at Last Connect was this blacklist table, where basically you would create a secondary table that you'd be able to add static C code and just say these items in the ACPI data structure are just to be considered gone and deleted, and you simply remove them from the data structure. But the point was raised that that will sort of punch holes in the ACPI data structure. And what that means is that you'll create unreachable nodes, right? So if you have a device hanging off another device, then you won't ever be able to get to any of those. And if your semantics are that you'll just want to not initialize and probe a containing device, well, then the whole thing breaks down, right? So instead, it was suggested that we leverage this underscore STA method, which is a method that exists implicitly in all ACPI objects that you can call. And if that returns, one of these values, but if, for example, if you return, let's see, present enabled decoding.
It should just be 0 actually.
It should be 0. Maybe I put the values incorrectly. But in any case, if you return a value that says the device is disabled, then the idea is if ACPI itself tries to do anything through ML bytecode, or if the driver should check this value and simply not initialize the device or access the device. And then have and Linux already does this and respects this, and we get that for free. Then the idea is to have this status override table, so you have a separate table, but instead of it saying completely removing a different device, it tells Linux to perform a pre-processing step where you go through and set the STA method on those devices that you want to override. So that sort of maintains the original tree and data structure while allowing you to still disable certain devices. So that's close to the previous approach, but that is currently what we're working on. So we have a proposal for a spec on how this should look like, and we'll work with Al, I don't know if he's in the room, but we'll work with the ACPI group from LEG on reserving that STAO table name and creating a pointer and saying this is the spec, and making sure that we can implement everything based on that. And then I guess we have time afterwards to figure out if we want that table to actually be part of the official spec, or if we just want to reserve the name. But at least in any case, it's probably reasonable to work with it and see that we have a full working setup before trying to include it in the spec. So in terms of upstream patch review for Xen, I don't think anything has been reviewed currently. So you guys should just fill in here if I'm wrong. It's probably not even been posted. Well, it's in a public Git tree, obviously. But But I think that's sort of one of the next things that we should look at, and it's probably worth a little bit of discussion on sort of what are you guys as maintainers? Are you ready to take patches for this? Do you want to keep it out of tree for a while? Do you want to just see it posted as RFCs? What's sort of your? Do you want to not see it before everything works? You know,
I think posted as RFC. I think posted as RFCs is probably the first starting place. So we're about 2 weeks from the freeze for Xen 405, and I think it's clearly not a Xen 405 picture.
It's probably not. I'm not even sure it makes sense.
It's not going to get applied in the next 2 weeks. So.
Okay.
But yeah, posting RFC.
But do you guys want to see it incrementally and just see patches as they grow RFC-wise, or do you want a full working solution? I don't know. It's basically up to.
I think probably better to see it sooner rather than later.
Okay.
And if there are bits at the front that we can cherry pick off and put it in sooner rather than later, then that's fine. Otherwise, it just keeps getting posted.
Yep. So Naresh, you should start posting the changes to Xen at RFCs, right?
Yeah. Because otherwise, the data you get pretty far down the line, and then you post it and you go, oh, no, we don't like that.
Yeah.
And then you have to go start again.
Yeah.
That's better than post it up.
All right.
Get that feedback out as well.
Okay. So we'll start moving on that. So another interesting picture. Some questions that we sort of just gathered up along the way, and I think to them, but let's verify them in this forum. So the question was raised whether we need to actually an instance of UEFI for DOM0, I mean after Xen has booted, to give Xen access to DOM0 services, or runtime services, for example.
We weren't imagining that you would.
No, I thought the conclusion at Last Connect was that you would, whatever information you need to pass from Xen to DOM0, you just use the device tree, and that would be it.
Device tree.
Device tree, right? How are you going to tell it how are you going to pass a command lines?
Well, that's what I think, yeah.
Yeah, so you have this tiny little device tree with whatever you need to tell it.
Yeah, understand the device tree.
Is there anything where DOM0 would need access to boot services or runtime services?
So runtime services, at least on x86, we have mechanisms for plugging through back into the hypervisor for things like if I boot variables and time, things like that, which I don't know how generic that is on the Linux side.
I think it's been posted. I think it has been posted. So Oracle is working towards upstreaming those changes. I don't think they're actually upstream, but the patches were pretty good. So not RFC, nothing like that. But I don't think they've been applied. So basically, there's a selector Linux that chooses whether to use the native implementation of runtime services, that is what we now call runtime services Linux, or an hypercode-based set of runtime services.
Okay, so I mean, I don't know to which extent the VM image standard applies for DOM0, right? But that specifies, for example, RTC would just be through runtime services calls, right? We probably need to think about that for Xen, how that works in this context. But certainly porting UEFI to run and boot DOM0 is a bad idea, right?
I don't know if it's a bad idea, but it's not necessary.
It's not necessary. That makes it a bad idea in my world.
I can see why people might want it, but no. Not.
Okay, all right.
There is at least one other runtime services call we might need, which is the reset calls, and then additionally anything for setting environment variables. If you're going to poke the bootloader to go and reboot, you need to do that for runtime services calls. You need access to that in DOM0.
Right, yeah.
Yeah, but you're not going to want a separate UEFI in DOM0.
No, sorry, I misunderstood the question.
Yeah, it's because then you'd be setting runtime variables for something that never happens. But you want to go back to the original UEFI.
Yeah, sorry, I misunderstood the question.
Basically, on x86 there is no multiple choice because of legacy. Many of the reasons they're going to do that. They left to do the runtime services baseline. So at that point, we just piggyback on that work.
Yeah, and then you can emulate whatever you want, whichever way you need it. Yeah, okay. I think we covered that one. So the other question is just sort of brain dump. What other things could be potentially down the road need to be accessed by Xen? Did we think this completely through?
The lesson menu is a big one, and in work with Charles, that is not here. No. From our towards packing out an SMU table, and work is progressing. Draft documents have been written. but has not been proposed yet.
But these are all static tables, no
Yes, so it would be enough information to get Xen set up the SME table just out of static information. PCIe, I haven't thought about it.
So I haven't thought very carefully about it either, but if you have any sort of images or anything you need to load for DOM0, that could all be done by your bootloader prior to booting Xen, correct? Right. So I can't come up with an example of why you want PCI support in the Xen hypervisor.
So I know that on x86 there is some PCI support in the hypervisor, but I don't know why or what.
Okay.
So you want me?
Probably to do with bridges.
Device pass-through.
Yeah, I think this works device path.
So quite a lot of device pass-through happens in user space.
It's also the case where all the boot.
Sorry, all the boot ROM entities in the start bridge lives in a PCI box. So you need to get PCI working to boot.
Maybe.
Yeah, so there's in the x86 EFI boot, there's a section where it scans for all the PCIe ROMs and loads the PCIe ROMs as part of the EFI boot. So whatever, some PCIe support will be needed to do that.
I think also on x86, the IO menus are keyed off of PCI IDs, so I think Xen needs to know enough about PCI bus to configure the IO menu. But I don't know if that would be true.
But how do they get the information if it's in AML?
I don't know.
You work on Xen, don't you?
Not on that bit.
So if x86 Xen, works with the PCI bus, and that is described, I don't know how that's described.
You just walk that in PCI CFG space. You can enumerate the PCI bus yourself without ACPI at all on x86.
It's a very standard way of doing it on x86.
The problem on ARM is that you're not going to know about the PCI host bridge.
Yeah, the root controller is
until you parse the DSDT.
Yeah.
Now I'm not entirely sure if that's correct.
So
In
there is
ACPI, because some of it may be in tables, but most of the functionality is.
There is a certain amount of stuff where the AML interpreter in DOM0 calls back to Xen and says, I discovered a PCI device.
That might just be the way it has to happen.
Yeah, which is
Which is workable. No, but it is workable, because then you've got a place. You don't have to have the ACPI. You don't have to run the AML bytecode in Xen. You can defer that to.
Yeah, so you don't find yourself in a chicken and egg situation where you can't boot DOM0 without having. But I think that doesn't apply in this sort of case. I'll say.
By the time you run Xen, you've already got the kernel in memory. You've already got the initRD in memory. You've already got the Xen kernel in memory.
Yeah.
You have everything you need to boot to the point of running AML. So you should be okay.
I think so too, but yeah, who knows?
Are you just looking for the PCI root info?
Yeah.
Yeah, so the question was whether you're just looking for the PCI root info. So there is a very specific table called MCMG that we need to add some parsing for. But that table contains the information on the root bridge.
And that's a static table.
And it's a static
right.
Right.
Well, problem solved.
Yeah.
What's the name again of the static table?
MCFG.
Alright, cool. So the question came up where this status override method, right? It only hides the device, but if you want to, say, describe a new version of that device because you alter its MMIO base address or something like that, and that device is described in the DSDT, then that's not going to work, right? So I talked a little bit to Ian before, and I think what I realized was that you guys are set on having the same MMIO map in DOM0 as the hardware, right?
Yeah.
Which would basically
Takes away a whole bunch of this possible.
yeah. But if we start mucking around just a little bit in that area, we have no good solutions. So we should be clear about this limitation.
We shouldn't muck around with that.
Right. But I think it's important to keep this in mind, right? Because yeah.
There are ways to do it that it's not trivial.
Yeah, I mean, as far as I understand, any way you could do that, modifying a device for that in the DSDT would require you to have an ACPI compiler, basically, right?
It would require Yeah, would require a compiler or would require using an SSDT to then modify things. But SSDT is somewhat limited. In theory, you're only supposed to be able to add nodes, but I'm not getting on that.
Yeah, you need to use it here.
So there is the SSDT, which will extend the existing namespace, right? So you can add devices with that. There are ways to build devices by kind of taking precompiled chunks of stuff, so you don't actually have to add in the entire compiler and interpreter. There's some BIOS folks that have done that.
Yeah.
They're not willing to share all of that, but it is possible and feasible. So yeah, adding in the SSDT is probably your best bet.
We do a bunch of that sort of stuff for HVM guests from x86, but
Yeah,
not
exactly.
from the hypervisor, but from the virtual firmware.
Right, so it's probably there.
Understood, I think,
code.
yeah.
You should be able to just reuse that.
Yeah.
Okay, so it sounds like we could find a solution even if we need to. Yep. But that applies to MIO base headers and. Did it work? That applies to MIO addresses and RQ line, right? So if you change the RQ number space, right, the same would apply, right?
Yeah, we should do that.
We do need to add one LQ. It's fine.
Just don't go,
I was just pointing out.
injecting,
Don't change any MMIOs or RQs, it's fine. Adding new ones.
Yeah, exactly. Yeah. Okay. Yeah, so that we already covered that. So then there was this case that we originally talked about this as the way we would do it. It's sort of an implementation detail, but worth just talking over. Would we copy the ACPI blob and modify it, add the STAO table, recalculate checksum, whatever is needed, and then pass that to DOM0? Or would we simply modify the one we're given by the hardware? We've talked about this previously as we want to copy it, but as Bhat and Naresh were implementing it, they were asking, well, I mean, you're consuming more memory, you're adding more code. Is there any reason why later on you need to have an intact copy in Xen of the original ACPI blob?
I can't think of one. Because for rebooting DOM0, you're rebooting the host, so then you get a fresh one from the BIOS. So,
Right.
So if your K is actually DOM0, you want the DOM0 modified one anyway.
So Xen won't go and do power management calls, anything with ACPI, anything it needs to go and read, whatever data it needs, it would extract at boot time, and that's it.
I think so. Grant's nodding as well.
Yeah, I don't think there needs to be very strict rules about who does things, and we've gone down the path. The ACPI blob or the AML it lives in DOM0. Period. None of no trying to run it up in Xen, because then who owns the context?
Yeah.
And it just doesn't work. It's not designed to support that. Static tables are designed to be. They are static tables, they're easy to modify. It doesn't really make any sense to have to make copies of them. And if we hit a situation where we need copies of them, we'll copy that table when that time comes.
Yeah.
There's no point in doing it now.
I mean, you have to copy the RSD, T and P and things to add the new stuff to them. Because they may be read memory, right? They might be a problem. Possibly. Depends.
It's just like anything else where you have to make code.
Yeah. It's like,
There's some address pointers in there, and you just have to go back and tidy those up.
And it wasn't about the difficulty, it was just finding the right arguments for implementing it the correct way. But the fact that it could be wrong actually tells us we do need to copy it, right?
we need to copy at least some, yeah.
And
All right. That's it. That's all we had. Any other questions? Any other input? Any other things we want to talk through? Yep. Naresh?
So just a basic question. If the goal of the status override tables is for Xen to be able to hide things from DOM0 without actually parsing the SDT, then by definition it means that you would need some platform-specific code in Xen to hide the devices you want to hide, because you cannot do it in a generic way to just parse it and decide that these patterns don't belong in zero.
So I think the things we're wanting to hide are things where they're in the AML and in the DSDT, but they are referenced from static tables by their path, their DSDT path. So we know the path, that's all we need to know in order to write a status code correctly, I think.
So the best example is a UART that is defined as static table and is also obviously the DSDT. And you want to write it because it's already used by Xen, so if you start using it, might not work or collide the same. So you need to, we already know that right to and it's generic, described as ACPI. So.
Okay, anything else? Questions, worries, concerns, suggestions?
So regarding power management.
Out.
So CPU power management should be PCI, right? We all agreed it was going to be PCI. PCI is already actually, as a matter of fact, supported by Xen. So, okay. Device power management, well, the device already owned by Linux. Linux has a device, as a CPI, fine. Platform power management. Yeah.
Before I try to answer, can you ask the question again?
So again, the CPU power management is done with PCI, not a problem because it's only Xen. And can do device power management is going to be done by Linux in Windows 0, and it owns the device, it owns the method of. It owns the method to perform power management on the devices. So if there is a platform level power management method, so first of all, described in ACPI. So yeah. First of all, is it common? Is it expect people to use platform level power management method? And if so, who is going to do it?
What are they? What do they do?
There are like so in device tree there are levels of power management and where you can use to basically save power on the entire SoC level.
Oh, right.
Right.
Right, okay. So the whole ACPI defines an entire, it's quite an elaborate state machine. The ACPI CA does all these things on saying the state of the entire system. And all that, the state machine runs within the context of the AML interpreter. And then it goes and it touches very specific things. So it will do the system, it'll do system power management, it will suspend the entire system, it will do the runtime PM. So it's not just that ACPI does devices. Devices are part of this big state machine that includes power suspending the entire system. So the problem for Xen, I think is what you're getting at, is the fact that DOM0 will go, well, I'm done. I'm ready to power off, and Xen's like, no, wait, I've got stuff going on here, please don't turn me off. I think the only way that we can handle that is there has to be a system state and a device state handoff, or a communication between the Xen kernel and DOM0, where DOM0.
Do we not have that in x86?
Yeah.
As you close your laptop lid, it eventually goes and says to Xen, now it's time to turn off.
Yeah, and that's what it has to do. So Xen basically has to have the ability to hold off transitioning to a power state,
Well, you see,
and have all these different levels within the ACPI.
So on x86, actually, this kind of power management, I think it's not very common because
The system does a lot of it.
But if you do it at a device level, usually it's as a network card, it's not used at all, let's shut it down, and that's fine for you to make that decision. But at the level of saying the entire system, let's just lower it down a bit, or let's power save a bit, but still keep it running, this is usually done at the CPU level, right? there is not such thing as a board level. But I mean, and
C states rather than B states.
That's C right. So there are a whole set of states for devices specifically. There's a whole set of states for CPUs specifically. But yeah, nobody actually has it.
I mean, that is good for the model. Yeah, right.
The closest they have is they do have a model for suspend and hibernate and on and off, right? And there are methods that you define and say, okay, go on, go off, go to sleep. I think there's like 5 different levels you can define there. So if you're already doing that on x86, it's basically the same ACPI method calls. Now those in turn may do something entirely different. But yes, that's going to have to be coordinated somehow between DOM0 and the hypervisor. And yeah.
If it's the same model, it's going to.
Actually, I will say a bit more. I think what does for the other DOMs, what facility does the kernel use to communicate up to Xen on what its performance requirements are?
PSCI as far as we've got really, so just idling VCPs.
Okay, so that'll handle the so for CPUs you've got the mechanism of I need the CPU, I don't. Yeah. So there isn't a mechanism right now for saying I need fast CPU.
No.
Okay, so
so that's something administrators can do at the host level. So say this domain is a fast domain, this domain is a slow domain.
Yeah.
There are processes to performance states.
Well, there's process to performance states, but I'm not talking about that in ACPI. I'm talking about you've got a bunch of guests, and each of those guests need a mechanism to communicate what power point it needs, or what performance point it needs. And Xen needs to coordinate that, or at least feed that information into DOM0. And we're having enough trouble getting CPU free working well with one operating system, let alone 5.
So that generally doesn't work very well in VM settings.
Yeah. So
VMs tend to either be running or not.
Yeah.
Yeah, and then you do your scaling on your host.
So that's one of the things that we at least have to have an answer for. And if the answer is we don't fiddle with that.
It is.
So the way
that's fine.
things happen on x86 then at least is that DOM0 and Xen between themselves will do CPU free to physical CPUs and based on idle times from
So
I think it started out. So Intel at the beginning implemented it by. I think it's just this story in mind. So at the beginning they did what seemed obvious, that is keeping all the infrastructure in Linux and just have Xen tell Linux to CPU frag. But that actually, I think, has some serious limitations, such as you need like a CPU in 0 on each of the physical CPUs and hard like that. I mean, it breaks down very badly the build of the physical like this stage.
Right.
So later on, I think a couple of years later, they re-implemented a little bit in Xen. So now it's implemented entirely in that provider. Xen provider is capable of doing CPU frag on its own.
So it does the direct. It's got its own governor within Xen.
Yes. That on Intel systems might be a good idea because there are not that many platforms to have to, drivers. While on ARM might be a different method. But I would just describe it.
On ARM ACPI systems though, which are more limited in terms of SPSA systems. I guess.
Yeah, I mean, if I remember correctly on Intel, CPU free talks directly to the hardware. Whereas on ARM, we're going to be using ACPI methods.
Right.
Because there isn't standardized. It's coming through. It's on the tape. Did not everyone hear me? Okay.
So we need to close the CPI method from Xen.
It's either that or Xen has to communicate through to DOM0, and I don't think you want to do it. If you do it in Xen, it means you have to pull the entire power management state machine up into Xen, and I don't think you want to do Okay, so but that's only one of the points that needs to be investigated. The other is communicating runtime power management information. Yes, for devices.
Right.
And then the third was the system state. And each one of those needs a mechanism of, instead of doing ACPI runtime power management, or embedded in the driver built in runtime power management, because you don't have all the knobs in that. It would need to be probably a Xen runtime power management driver.
That
Okay, for
works
this
well
device.
in x86. So to be honest, so if a regular VM, we don't have any real devices attached to it.
Yeah.
So that is the simple case to handle. A virtual machine with a device, a physical device assigned to it, basically is not handled. Because usually you don't want to allow the virtual machine, that is an unprivileged virtual machine, is not on zero, like you're a regular guest. You don't want to allow it to fiddle with the power management of the device. Right. So although originally did not piece of history, originally, but remember, we probably implemented the capability of allowing the guest VM to power manage the device. It was never turned on by default. Actually, eventually the feature disappeared. So now I don't even handle it anymore because nobody was using it.
Right. Yeah.
Right. So it's less of a problem.
So if there aren't any other questions, that's it. If anybody wants to come and take a look at the stuff actually booting and looking at stuff we may have missed, go find Naresh in the virtualization hacking room, and hopefully we'll have Zero and everything running by the end of the week, right?
All right, it was running already.
What, sorry?
In the stuff you said was running already.
The hypervisor, not Zero.
Oh, okay.
I was very specific on that point. All right, thanks everyone.
Yeah, I have it.
Lunch?
When's the lunchtime now? It's actually shorter than it's supposed to be.
Yeah, then you should have been here at the previous session, that was like 5 minutes.
It's going. All systems go, is it?
What is the plan for the afternoon?
Sorry?
What is the plan for this afternoon?
I don't know, but we'll have lunch and then we'll all meet and then we'll figure it out. So I should go, I've been told I should go to the employee meeting at 4:30, which would mean that I can't really go anywhere in the afternoon, so maybe we should just go out for dinner. Yeah, I think maybe we should just do an early dinner as the team.
Yes.
I tried.
Good shame. It's not too bad. Yeah, it's I think that, well, I'm maybe a third of the way through.
Yeah, don't worry about that one. I will. Yeah, it's on the family. Yeah, it's on the. Okay, great. Thanks.
It does. Well, I suppose I'll try to go to Thank you. All right. I'll just been working. Chop, chop.
Do you have any clue?
Yeah.
I think we're going to go for a place called the Stanford Dish. So might walk around there. But Christoffer hadn't actually confirmed what we were doing.
We will do the what is the program for this afternoon?
We will go